Welcome to our North Central Climate Collaborative webinar for February of 2025. We're really happy today to have Dr. Maninder Singh with us from Michigan State University. His topic today will be turning weather-related challenges into agronomic management opportunities. Dr. Singh comes to us as an associate professor of cropping systems agronomy at Michigan State. That's in the Department of Plant, Soil, and Microbial Sciences. For the webinar today, we do have the chat function open. If you need to send a message directly to us, the hosts, or if you have technical issues, you can use the chat. But in general, if you just have a question for the presenter, please put that in the Q&A. We will hold all the questions for the presenter until the end. And we encourage some discussion, threads throughout as well if you guys have some questions or some discussion you want to share. So keep that in mind. That will hold the questions just till the end. So Dr. Singh, thank you for joining us today, and I'll let you begin.
All right. Thanks for the introduction, and good afternoon, everyone. It's been a nice day over here in Michigan. So hopefully a lot of you guys don't have to deal with some of the weather challenges we have had. And that sort of relates to our topic here as well. I was thinking what I should be focusing on today. So I always like to give for these longer webinars, what we will be talking for the next 45 minutes. So as my title suggests, we're going to start by looking into some recent climate trends. I'm an agronomist, right? So I will try my best to at least explain some of the data I get from our climatologist. And then sort of before we go into, how do we sort of, use these trends to our advantage? I always like to focus on, what are we trying to do in terms of when we are talking, bushels of corn or beans, what are the basic concepts we are trying to chase. So we will go over some of those, and that hopefully will help us lead into this, okay, what can we do management wise, to maximize our yield, even profitability, where the grain prices are this year. That is probably top of mind for a lot of people, right? You can see a lot of those decisions that we will go through, mostly focus on these pre or at planting decisions, right? Short term, probably thinking about this growing season. There are a lot of long-term implications as well that I won't go into too much detail, but love to have some chat towards the end. As was said, that we will do some Q&A at the end. And you can see three nice pictures at the bottom. That's what my specialty is. So we'll focus on corn and soybeans for the most part, and winter wheat is a big crop for us here in Michigan. So I'll show some data on that aspect as well. So yeah, when we think about some of the recent trends, the first one I would love to talk about is the temperatures, right? And you all probably have seen data that we have been trending warmer over the last few decades, right? But the one aspect I want to focus today is the length of the growing season that you can see in this image. For Michigan, other states in the northern belt, length of growing season is one of our yield limiting factors, right? So some of these trends probably are working to our advantage. Here you can see this black line towards the bottom. That's showing your last or spring frost event. And that has been moving earlier over the last few decades. And then at the top, you can see this red line. That's your first or fall frost event. And that has been getting later over the last, again, few decades. And that leads to this frost-free days that's in the green line. You can see over the last few decades, we have gained quite a bit, right? This data is from Lansing, but similar trends are occurring in other northern production systems. So again, the question becomes then how we can utilize these data to our advantage, right? in management decision making. Adding on to that, another piece we have seen is the change in amount of heat we are receiving even within our typical growing season of May through September, right? Growing degree days is the concept we all use in terms of crop growth and development, right? You can see this map for Michigan and a few other northern states here. Back in 90s for mid-Michigan area, we used to have about 22 to 2400 growing degree units. Well, if we look at these maps over decades, you can see from 90s to 2000s to 2010s, you can see these colors are getting darker. That means that we are getting more heat in that summer period, right? Is it a good thing, or are there potential negatives there? Probably, right? More heat is probably good for crop growth and development unless we go beyond temperatures like the 86 degrees we use for corn and beans. Then again, it can cause stress and have some negative implications, right? So keep that in mind. The second trend I want to talk about is we have been getting wetter over the last few decades too. This figure at the top, you can see this trend since 60s. You can see this trend line has been moving upward. Total amount of water precipitation that is coming into the system, which probably is a good thing, right? But the distribution of that rain amount is very critical. And what has been happening, as you can see in this figure towards the bottom, is the number of events, heavy precipitation events, have gone up quite a bit. Much more in the Midwestern area, but probably true everywhere else, and even in the Northeast. So we are getting more water, but it's coming in these heavier, less number of events, especially in the spring as well as in the fall when we are out there planting or harvesting our crops, right? And that's leading to reduction in number of field days we can be out in the field with our equipment. You can see in this figure here with these different colors that number of days per decade we have lost within this April to May planting window, right? And you can see some variation, but yeah, some states have lost quite a bit. Giving you a specific example here in Michigan, over the last again 25, 30 years, you can see we used to have 20 to 25 days to be able to do the field work in this April to May window. And now we are down to 15 to 20. So we have lost number of days, right? The temperature is working to our advantage. We can be out there, but if it's too wet, now can we still be able to do our field work, right? So that creates a lot of challenges, right, in terms of implications. There probably are some positives, but there are probably plenty of negatives, right? So one might need to be rethinking, okay, what is the ideal time of the year to start my field operations, right? When do these soil conditions turn, optimal for us to be out in the field to do any field work, or what are the good conditions for the crops we are focusing on, right? And we'll talk a lot about corn and beans. What sort of equipment I should be using, right, with dealing with these kind of conditions. And that's where a lot of crop decisions come into play, right? When do I start planting? What crop to plant first? That's always something that's top of our growers' mind here when we roll into early April. Shall we keep planting corn early, or is there maybe a potential for getting soybeans planted ahead, right? What should be my optimal varietal maturity with this change in the length of growing season? Can I take advantage somehow, right? How critical is that seed placement piece? And then all these at time planting decisions, what are the season-long implications in terms of crop growth, development, and eventual yield, right? And that's where the sort of the concept of crop production comes into mind, right? What are we trying to achieve? How do we make those bushels at the end of the growing season? And the concept I always go with this source sink sort of a deal. So again, our main goal here is developing this uniform and healthy canopy early in the growing season that can help us maximize amount of sunlight those crops are able to intercept, convert into biomass, right? That's what we are trying to do, right? So that's where knowledge of crop growth and development is very critical. Also, knowledge of our fields are very critical as we deal with these weather extremes. That becomes even more important. A lot of the factors that cause yield limitations might be field specific, right? So knowing those are important, and then we have to make sound agronomic decisions to minimize any of those limiting factors, right? But this is to produce more biomass. When we are thinking about grain crop, that is not the end, right? We are trying to produce as much grain as we can, right? That's where the sink capacity comes into play. Essentially, what are the contributing or the components of those bushels that we are chasing when they occur during that growing season? And that's very critical because once we are past those critical stages, we cannot recover anything that has already happened, right? To give you an example for corn, we think about, one is number of years per unit area, right? And they sort of are determined earlier in the growing season, anywhere from emergence to that to the two leaf stage, right? The number two is your kernel numbers per year, right? And that starts happening again very early in the growing season. Number of rows on that year as early as V6, right? Kernels per row around V12 or so, the plant is already determining those factors. And by R2 or so, number of kernels are actually finalized. And then kernel weight is the one that is being determined at the end of the growing season, right? So the important piece here is that yield components are being determined throughout the growing season, sometime even before we can see that with our visual eye, right? So that's an example for corn. Same thing holds true for soybeans here. You can see these different yield components here as well, right? Number of plants, pods per plant, then number of seeds per pod, and eventually that final seed weight, right? Typically, our goal in soybean production is how we can maximize the number of pods per plant, or I would say number of pods per unit area, right? That's going to give us a number of seeds per unit area. And that's generally the way to maximize soybean yield without causing any decline in seed weight. So just like corn, knowing when these are occurring in the growing season is critical, right? During that early R stages, R1 all the way through R4, R5, that's when we are determining that number of seeds, right? So making sure that we have enough of that leaf area out there and maximizing the photosynthetic capacity helps us increase that number, right? While in that seed fill duration from R5 to R7 is helping us to maintain the weight of those seeds. Otherwise, if the number goes up, the weight goes down and we don't gain much, right? So these principles become even more important as we deal with some of these weather events. All right, now let's start talking about management decisions, right? And again, as I was talking before, the number one that's typically on top of people's mind is what crop should I be planting first and what are the implications of that planting time. And as you can see in this picture, year in, year out, we do a lot of research trials on various agronomic variables. And of all the ones we can study, planting time helps us develop this nice closed canopy early in that growing season, as you can see here with this April and mid-May planting times, right? And as the planting is delayed, now you can see that the canopy is not closed and we are already losing some sunlight. There might be some implications with weed control here, probably soil moisture loss as well, right? So again, planting time does impact crop growth and development, probably more so in northern states than central or southern states because of that limitation in the growing season, right? And timely planting does help us sort of, with a potentially a little bit of a longer growing season, so to speak. And this picture sort of relates to these data that we collect again every year. A lot of plots goes into each and every of these data points. You can see we start planting soybeans around here in mid-Michigan about mid-April or so. And then you can see my y-axis here is relative yield. So to compare between years and locations, we relativize. Our yield potentials vary anywhere from 50, 60 bushels up to even 90 to 100 for soybeans, and then anywhere from 180 to 240, 250 on the corn side. But I'll be showing you data in relativized yield, right? When you look at this first data with soybeans, couple of things come into mind, right? As we are pushing towards these early season planting conditions, there's a lot of interest, a lot of popular press articles on early season soybean plantings, right? You can see that there was a long plateau on this curve, right? As we are pushing towards this early season planting, our optimal was around this end of April time. Earlier than this, we did not at least lose any yield with those non-ideal cool and wet soil conditions, right? So even though we didn't gain much, but we didn't lose a whole lot. We were still doing pretty decent as long as we were able to plant by the typical time of mid-May or so. And then you can see that yield starts declining at a much faster rate. So the numbers we might typically see out there, half a bushel decline in yield per day, delay in planting, it's not exactly valid, right? The curve is not linear, it's more of a curvy linear. Early on, the decline is less steep and then it becomes more steeper, right? But this looks very different compared to these corn data, right? Here you can see that our optimal with this dotted line was towards only early May. And as we were pushing towards these early season non-ideal field conditions, a corn plant did not like it. And we ended up having actually a yield loss. So it kind of makes sense because corn likes to emerge, uniformly. Everything needs to be at VE, V1. If you have a V2 and VE plant right next to each other, they're sort of competing, right? While a soybean plant, again, is able to branch out and compensate for any sort of a relative loss in stand, right, by branching out. A corn plant does not do that. So this sort of gives you that idea that, yeah, while timely corn planting is still critical because there is a bigger penalty in yield with delay in corn planting, there is probably that early window when the things are not as ideal and a soybean plant might be more forgiving than the corn plant with those non-ideal conditions. And again, with the higher amount of rainfall we are getting in the spring, this probably becomes even more critical, right? So again, with that interest in early season soybean planting, I was part of this multi-state group led by Wisconsin. You can see all the locations on farm where we did these trials, essentially comparing farmers' typical planting time, which here in Michigan was about mid-May or so, and that's on your x-axis, these reference yields, to the improved, which was again generally 2 to 3 weeks early, along with maybe few other management. So there's a potential confounding factor here, but mostly early season planting. And any data point above this red line shows you the benefit of early planting. And you can see for the most part, a lot of our fields were above that line, right? Across all 3 seasons, you can see our yield gain was anywhere from 3 to about 5 bushels per field, right, per acre. And that led to anywhere from $30 to $50 increase in profitability because it does not cost us extra money, right? Another important factor, what we can do without increasing our input cost. And early or timely planting seems to fit that bill. Here is some data from the same project focused only on Michigan locations where we have about, again, 35 on-farm trials, right, working directly with farmers. And here, pretty much any number that's above zero is only because of early planting. So it was a direct comparison, early versus typical planting time. And you can see more than half of our fields were able to benefit from that early season planting, anywhere from 2 bushels up to 7 bushels or so, right? So shows you the potential benefit of early season planting of soybeans. But again, life is not that simple, right? And you can see towards the right of this figure, there are few locations where we did lose yield, especially this one location in Branch County where we almost lost 7 bushels. The grower did plant very early in the growing season. I believe April 7th. It was a no-till field, and then we had a frost event early May, caused a lot of reduction in our stands. Soybeans again are forgiving. We will talk a little bit about replanting, but again, you have to have at least a minimum number of plants out there to at least be able to close that canopy, have minimal issues with weed control and things like that, right? So the risk is still out there, right? So again, in terms of this early soybean planting, the reward is there, as we have been talking, increase in yield, if not that, at least extension of a planting window. So we are not getting a penalty with the delayed planting, but the risk is out there, right? Poor stand establishment because of germination or emergence issues, right? Uh, you all have seen soybeans, when they get frosted early, again, they do have those auxiliary meristems that can sort of lead to those extra shoots, as you can see in this image, right? So again, that's where a soybean plant can be more forgiving. That stage when it's coming above ground, it's sort of very critical for a few days, but again, a few loss in plants, or if the apical meristem is dead, you might still get around it. There's a crop insurance piece that I will talk about in the next slide. But sort of, when I talk to my growers, the idea with early season planting is we are focusing on the field conditions, not on a calendar date, right? And targeting fields that we know, are suitable for early planting, where we have drainage, that there is not too much topography or slope in those fields, right? Maybe a little bit light ground. So again, knowing those is very critical. Monitoring soil moisture and temperature is very critical. We used to have a threshold of 50 degrees to start planting. For these new soybean varieties, we have seen even in mid 40s, they tend to do okay. So again, that's probably okay, but the soil moisture piece is very critical, that we don't want to mud the seed in, so to speak, and cause compaction and things like that, right? So again, targeting fields is a good way to go, while knowing that soybean plant seems to be more forgiving to these early season non-ideal planting conditions and any potential loss in stand, compared to a corn plant where it just does not like that, right? I have worked with our soybean agronomist group across various states, a part of our Science for Success collaboration. We were able to work with RMA to move some of these crop insurance dates earlier. As you can see in this figure, as an example, in Michigan, I think pretty much most of our counties moved earlier by 5 to 7 days or so. And I believe that was true for a lot of other states in this map. So again, make sure that we know these dates and we are able to update our growers about these changes that can work to their advantage. All right, so moving on. So planting time is again critical for us, especially in northern systems, right? I have shown you this curve before, right? But that's not the end of the game, right? We sort of think about, how we can change the trajectory of this curve. How again I can improve the benefits of early season planting, and then we know we can't plant on time or even early all the time, right? 2019 comes to mind. Delayed planting is again inevitable, and then the question becomes, how do we minimize any yield penalty that comes with the delayed planting, while keeping that ROI profitability in mind, right? Especially where the prices are. We don't want to increase the input cost too much to gain any bushels, because then we might not be able to make any profits out of that, right? This is something a farmer has to deal with every year, right? Because unlike a researcher, they cannot work in a silo, look at few factors. In our program, we have what I call my laundry list of variables, that we typically look at. How do we develop this, management portfolios based on when we are able to plant, right? We have done a lot of work on variety selection piece. We have done some work on seedbed preparation, tillage practices. We have looked into seeding rate and row spacing interactions, so to speak. We have also looked into seed quality, these early season again conditions. Making sure we are using high quality seed is very critical. Just the warm germ that's on the seed label might not be enough. Doing some cold germ, some accelerated aging. There are a number of other tests that are out there. Getting more data on that piece is critical. Seed treatments, again, probably are more beneficial with these non-ideal early season planting conditions. With the delay in planting into June, probably not as critical, right? So again, a lot of factors here that we do look into, and the farmer has to think about. Today, because of time limitation, we will start by looking into this varietal maturity selection piece. And then we'll tie that with a little bit of harvest timing as well, right? Because that's very critical. We can push for longer or different maturities, but if we can't get them to mature and harvest on time, that's not ideal, right? And then how do we get plantings on time, right? Planting methods is an important piece there. What is the importance of uniform seed placement, essentially, right? So we'll end with that topic. All right, so starting with soybeans here. You all probably have seen this map, right? A few researchers have done this over the years. This is probably the latest uh, iteration of this. And you can see again, uh, these maps use data from variety trials that are pretty much ongoing in most of US states. And based on that, uh, most of the states have their own maps. So as an example, you can see this map for us here in Michigan, right? We are mid-Michigan, we are about 2.5 maturity group, right? And for the US, again, goes all the way from double zeros, in the northern systems to maturity group 6 or so as we move towards the south. The limitation with these data is, again, that the variety trials that these are based on are typically planted in that sort of typical planting window, right? Uh, those researchers are not pushing for early, or they are trying to avoid late planting. So the question becomes, again, as our weather is shifting, with the trends I was showing you earlier, with that length of growing season, earlier spring frost, later fall frost, what is the interaction of this maturity selection with the planting time, right? That is something we do look into in our program, and I believe we need more data across the states for something like this. As an example here, you can see that we in this research, we planted all the way from end of April toward end of June, using maturities all the way from 1.0 to 3.5. And different colors here gives you different yield. With the green here actually means lower yield. And as we go into orange, that means higher yield potentials. As a reference, 2.5 is the typical maturity here in mid-Michigan area. So if we look at these data, if we were in this typical planting of May, mid-May or so, these colors don't change actually. So there is a lot of sort of, potential to pick whatever variety we like, because there's 10 other factors while selecting a variety that a farmer needs to look at, right? So the association between that varietal maturity and yield in this typical window is really not there. However, when we push towards these early season plantings, that's where you can start seeing most of these lines are bending upwards, right? So here we are able to see the benefit of using these longer late maturing varieties because now we have a longer growing season in front of us, right? And we have done this over multiple years and have seen some of this consistently. Weather again is a big determinant of soybean yield, right? During especially during the time of July and August. But again, we have seen the benefit of planting early and going to these longer maturing varieties. On the other side, as planting gets delayed, we have seen that going towards early maturing varieties by half a unit or so up to a unit does benefit. And double cropping comes into mind as well. We are typically too far north that a lot of our growers don't do any double cropping, but there's a lot of interest now. The crop insurance piece is in there too, that there are more counties with crop insurance coverage for double crop soybeans. So again, that's where our recommendation is that don't use that typical maturity map. Try to think how planting date and double crop soybeans are very late planting comes into that equation, right? And this idea about yield benefit going towards early season planting and late maturity varieties, it comes back to the yield components I was talking about before, right? That to increase soybean yield, we want to increase number of seeds per unit area. And we did see that. When we planted in late April, we'd see a nice increase in number of seeds, right? Now we have longer season. The plant is able to spend more time in the vegetative period, right? Putting out more number of nodes, spots, and seeds, right? But typically what happens is when your number of seeds goes up, your seed weight might go down. But here, when we push towards those longer maturing varieties, that do spend more time in R stages as well, we did not see that. You can see increase in the number, but the seed weight on this right figure did not change. So that's where we were able to see that yield benefit of going early, pushing for about half a unit up to less than a unit in varietal maturity. All right, now switching gears, let's look at the corn side, right? And we were surprised actually that unlike that soybean map I showed you, there has not been a really well-developed corn relative maturity map for US. So we have been working as part of our research team, uh, and this article is still in review, but you can see this is a new map for corn relative maturity selection. Again, using data from variety trials, right? And you can see the range as you would expect anywhere from those early 80s all the way to late 100s. Folks do use the term days here, but that's a misnomer, right? As an example, this 98 RM hybrid does not take 98 days to maturity, right? It's a relativized scale compared to a different hybrid within that same company's portfolio. Actual number of days vary a lot, but it's a scale that still works. And again, using something like this, we have just pushed out data map for Michigan growers as well, right? So again, uh, these data are coming from those variety trials, corn performance trials, which are again planted in that typical window, not early or delayed, right? Just like corn, we have looked at that. What is the relation between planting time and relative maturities, right? As again, we are dealing with this shift in our growing season, right? Both temperature and precipitation wise, right? So something similar to beans here. You can see our planting times going from end of April all the way to early June. And then we use our maturities from 90 to 109, with about 99 RM being typical for mid-Michigan area here. Something similar to beans here, you can see that there was again more of a trend, more of a relation between relative maturity, or what I call growing degree day accumulation for a given hybrid, and its sort of yield potential, right? Even during that typical planting window, but more so as we were trying to push towards those early season plantings, which again did not always give us high yield, like uh, unlike soybeans, right? Again, corn does not like these some of these very early season planting conditions, so we again have to be careful. But we did see a sort of a trend of going towards early planting and then pushing a little bit on that relative maturity by 5 to 7 units, something like that. While planting gets delayed, unlike corn, unlike soybean, sorry, we did not see the need to switch to early maturing hybrids as quickly. There is a phenomenon in corn called growing degree decompression, where if we plant the same hybrid, let's say on May 30th versus May 1, it takes less heat, less growing degree days to reach maturity. So that phenomena works to our benefit. We still have to switch maturities with the delay in planting, but again, that compression phenomena provides us with a little bit of a hedge, right? So again, we sort of recommend folks, to go with the what I call a portfolio approach, right? Where you are sort of, putting your hybrids about 10 relative maturity units apart, sort of, right? So to create variability, genetic variability, hedge against weather conditions and things like that. And if possible, going with those late maturities for early season plantings to achieve some extra yield benefits, right? How do we do that? Again, planning again is going to be name of the game going into future in ag, right? This is where use of new tools, new technology comes into play. A lot of you folks might be aware of this useful to usable tool in corn, available on this website, free to use, very handy tool where one can enter their location, the planting date, and then the corn hybrid's maturity, either that RM rating or the growing degree day. And this tool spits out the days to silking as seen in this red line, and then the days to physiological maturity. And it even spits out these other bars that's showing these blue ones showing you the potential for frost event, right? And it even compares the growing degree days for the growing season in this green line compared to a long-term average. If some of you probably remember last year, at least here in Michigan, we were relatively accumulating more growing degree units. So again, a really nice tool that does do a decent job. It does not account for that growing degree decompression phenomena I was talking about. It also does not give you the time to harvest, right? Because if we are trying to maximize profitability, drying cost in corn is an important piece. So we have done some research over the last few years here in Michigan, looking at what are those dry down rates look like for corn, including what are the plateau levels, right? As an example, you can see that R6 stage I was talking about at black layer, over the years, the range when that black layer happens does vary, right? Anywhere from 28 to low 30s. 2023 was sort of an anomaly. It was a relatively wet year with low growing degree days around here, and you can see that our moisture levels were high. And the plateau levels, again, typically we are able to achieve below 20%, right? Which is again close to that 15.5% selling moisture, right? And down bottom, you can see some of these numbers. We typically use about 0.5% moisture loss per day as a rule of thumb. And you can see our numbers did relate to that threshold, maybe a little bit higher. And we were surprised even with late plantings and use of these longer maturities up to 109 RM. We were still able to maintain some really good dry down values going into even October or early November. So something to keep in mind. We are working on upgrading that U2U tool to account for, again, provide grower with a harvest date estimate, right? So I think there's a potential to sort of plan corn harvest timing a little bit better. And that's where in-field estimation is critical. We have looked at some sort of, NIR sensors as sort of a way to quickly estimate moisture in field. And you can see the one we were using here compared to the oven dry method over 3 years, spot on, with the moisture range all the way from 60% all the way down to 15. So even for high moisture corn, this does seem to work very well, right? This is the information on the sensor. We did publish this data last year. They do have an annual cost in terms of software, but I expect other companies are jumping in this fold, and there would be more options that might be a little bit more cost effective. But again, there are options that do exist in terms of very quick estimation of moisture in terms of determining when we can harvest or how much delay we can afford, to maximize our profitability. All right, so moving on to the very last piece, right? We're talking about timely planting, right? More so probably for beans, but even quick enough for corn. So uh, one can think about, what is the importance of seed placement, optimal seed placement versus timely planting. So when we think about seed placement, this is something we probably don't want to see, right? In this first cartoon, you can see there's a lot of variability in that planting depth. And then you can also see a lot of skips, a lot of doubles. So a lack of singulation, so to speak, right? Compared to if you look at this picture on the right, this is what one would like, right? Uniform depth, uniform seed to seed spacing. So now the question is, how do crops respond to the seed placement, right? And do they respond similarly, right? Because we know that we probably like to be towards this right side, but if we don't have the right equipment or the equipment is tied at planting one crop, we might not be able to achieve that. And can we get by with something like this left cartoon, right? There's a lot of research in the corn world, and we were talking about that before. It likes the even emergence, all that. All the bells and whistles we can afford on a planter probably does pay off. Getting the ideal seed placement in a good seed bed, right? Uh, for that even emergence, and corn likes that. I'll show you some data that a soybean plant, because it's able to branch out, as we were talking before, is a little bit more forgiving. So even though not ideal, but variable seed placement, if we can get the timely planting, is okay. So I believe timely planting is more critical than achieving that seed placement. We have done this work on a lot of small grain crops as well, mainly winter wheat. That is an important part of our rotation here in terms of crop diversity. Another way to again minimize issue of these weather events. And I thought that might fall in the middle, but yeah, we have some new data to sort of show where these crops sort of behave, right? These were the planting equipments we were using. So again, a standard precision planter that you all are aware of, where we are again singulating seed, right? But it does have high upfront cost. Probably we can't cover too much area, or if we are planting at a very high seeding rate, winter wheat, other small grains comes into mind, that it's probably not as ideal, right? And for those crops, again, we have been stuck with this conventional, what I call spill type drills, right? Where we are metering the seed out, but it's not very precise, right? But it's available, gets the job done, but we don't know what's the benefit of a more ideal seed placement for those small grain crops, right? As we again deal with these weather events. And then some of our growers actually were going the other way around, and they were going with this technology where they are using a tool to uniformly broadcasting seed in the field, and then a shallow tillage tool to incorporate, with the idea that one can cover a lot of ground in a short amount of time. But what are the yield implications, right? So we did this project on farm, again, mostly with winter wheat. You can see drill as our control. Few growers had a air seeder as well, and we compared that to a custom build, uh, again, precision planting system in narrow row spacing, 5 or 10-inch rows. And then we also looked into a couple of these broadcast incorporation systems, where again, that uniform distribution of seed is very critical. Otherwise, that can be a recipe for disaster. So again, one might be wondering, what sort of seed distributions did we achieve? And here is some data from one of our location. As you would expect, within the soil profile, the drill was all over the place, right? We were shooting for inch and a quarter, but we were again more variable. When we went with the planter, again, we were spot on, as one would expect. And as one would expect, the broadcast incorporation was the most variable, right? Looking at these data, one would probably think the benefit of the planter and then the disadvantage of the broadcast. One of that is true, one is not, and I'll show you some of these data. Starting with again that precision planter, we did this comparison at 8 on-farm locations, and 4 of those locations we did see a significant yield benefit with that precision planter in narrow row spacing, 5-inch rows compared to 7.5 for drill, anywhere from again 10 to 30% roughly. Even the locations where we did not see differences, that system still was numerically the highest. And that sort of made sense, right? As I was showing, we had a reduction in depth variability led to more emergence of those wheat seedlings, resulted in more number of heads per unit area. We also saw some potential for improving quality. Dawn or vomitoxin is a big issue for us here due to fusarium head blight. And that optimal seed placement led to more uniform tillering, and that improved the efficacy of the fungicide that we were applying at the time of flowering in wheat. So again, some multiple benefits here, right? And that was expected. This was not. When we compared the broadcast with the drill, most of our site years fell in this last bucket here. We had these 3 site years where, yeah, one method did better than the other, not by a whole lot, but most of our site years, 14 out of 17, we did not see a yield difference when we used a drill versus an air seeder versus broadcast incorporation. And our yield potentials were anywhere from 50 all the way to 150 bushels per acre as well. And that was a surprise to us early on, that there is no yield, because no difference in yield. I did show you higher depth variability in broadcast. That did lead to low emergence. But the reason for this non difference, I believe, is that we had more number of heads per unit area or per unit plant when we were broadcasting. And that, I believe, sort of, save the day for us. And that it sort of comes down to this idea, when we think about this mathematical way to, see what's happening in the field, right? In 7.5 inch row spacing, a lot of our growers are about 1.5, 1.6 million seeds per acre. You are getting almost half-inch seed to seed spacing and a lot of variability, right? So one might ask, is there even a benefit of singulating at this rate, right? And the answer probably is no. What we are seeing is that when we go to these precision systems, go to narrow row spacing, cut down our seeding rate. Now we have more linear footage to work with, right? Now we have almost close to 2 inches between those seeds. Yeah, now we probably can see some potential benefit of that optimal seed placement, right? And one can keep going on this road. If you cut down that seeding rate even more, you can create this sort of what I call equidistant spacing around that seed. And if I'm that plant, I probably like this, right? But at a minimum, I probably would like what's in the middle and not what's on the left side, right? So this is where I think we are gaining some of these yield benefits, especially dealing with non-ideal seedbed conditions, right? We have some data on the soybean side as well that just like wheat, they tend to respond to narrow spacing. And we have done some research looking at 10-inch soybeans as an example, or 15-inch, and see if one can invest in this multi-crop equipment that's sort of geared towards a narrow spacing, right? Unlike a corn planter, which probably again there has not been too much benefit going from 30 to 15-inch rows. So that's sort of the thinking we have. Here is some data that I was just talking about, that in soybeans, we have tried these, again, different seed placement methods. Within each of these site years, from left to right, it's less to more precise seed placement method. And you can see some of our yield data variability was there. And typically, we did not see a huge reduction in yield when we went with the non-ideal seed placement method, right? And that probably made sense because just like wheat, a soybean plant is able to branch out, right? While a corn plant does not do either of that, right? So while optimal seed placement is still critical, but if we can plant a lot of area early by using a less precise technology or planting at a faster rate to cover more ground, that probably is beneficial, right? And again, something similar to the previous slide, because soybeans are more forgiving, we have revised our replanting decisions. Again, as part of this Science for Success multi-state group, we have this really nice fact sheet that I highly recommend folks to look at, where again, we ask people that if you are planting early, you're going to see some stand loss, then what's that point where you decide, do I want to replant or what we call a repair plant when you're going in and just, filling low spots or do nothing. And a lot of our colleagues have seen that, yeah. For the most part, you do not want to replant a soybean field. Repair planting or doing nothing might just be enough because again, a replant is always a delayed planting and soybean plant is more forgiving in terms of, again, need for that very uniform stand that a corn plant likes, right? So something to think about as we deal with these non-ideal planting conditions and as we deal with, again, change in some of these weather events over years. All right. So to wrap it up, again, we are seeing some of these trends in terms of warmer and wetter seasons, right? The length of growing season is expanding, which is a positive, but we are getting more water during spring and fall when we potentially don't need it. And actually, there is little bit similar or maybe reduction in the fall. So again, that's giving us some challenges, but also some opportunities. And that's where real good knowledge of crop growth and development is critical. That source and sink relation, knowing what are the yield components for the crop I'm targeting when they are being determined in the growing season, right? So we are not behind the game, so to speak. In terms of, again, management, timely planting is critical, especially in northern production systems. Ability to plant more acres in less time, if we can do that, that's good, right? That's what maybe future investment might need to go into. Soybean plant can tolerate these non-ideal early season conditions, right? That can lead to non-uniform plant stand compared to a corn plant. So the replant considerations do vary. For soybeans, again, we recommend that as long as you are down to even down probably 60,000 plants or so, relatively uniformly distributed, replanting is not needed, right? The fact sheet I was talking about is a really good resource there. Corn is very different, right? Does not behave like that. Picking the right varietal maturities based on when we are able to plant now and going into future is very critical. Accounting for this extension of growing season and the planting times, going with that portfolio approach I was talking about is very critical, right? And then investing in new technology, right? These narrow row planting systems, a second planting system to cover more ground, right? Use of tools to make harvest decisions, things like that is going to be helpful, right? And then something we have not discussed much in this talk, but again, there are practices that can help improve soil health. You all probably have heard about that topic, can help improve the system resiliency, and that can help minimize some of these weather risk and lead to more stable, if not improved yields, right? What are those practices looking like? Again, going to some form of conservation tillage, right, does help, right? Especially if we are looking at soybean production and wheat production, right? Diversifying our crop rotations definitely help. Here in Michigan, we recommend people, if you're not growing wheat, winter wheat, please do so. It is beneficial. It can make profit if you do it right, and it improves corn and soybean profitability. Cover crops probably come into that same breath, right? Thinking about those practices will be really useful. With that, again, all the information I talked about will be on our website, agronomy.msu.edu. So you can find a lot of articles, presentations, fact sheets there. And lastly, I would like to thank everyone who helps me do all this work. Again, it's takes a lot of time, a lot of effort. So a lot of check of dollars, that a lot of our growers contribute towards. So really thankful for all those things. And I think we have decent amount of time for some questions and good discussion. Thank you.
Thank you, Dr. Singh, for a great presentation. I think that was a great breadth of different crops and some of the climate weather challenges and opportunities, as you say. Yeah, it's certainly similar here in South Dakota with longer growing seasons and wetter conditions overall. Very much
Mhm. Yep.
we
Yep.
experience the same here on the western side of the region. So we don't have any Q&A, any questions in our Q&A at this point. But I did want to mention we are recording this webinar and it will be available on the North Central Climate Collaborative website. Allie put that link in the chat, but we can drop that again in case some of you missed it earlier on at northcentralclimate.org. I'm trying to think if I had any other I don't have any other questions to start with. I wanted to give some opportunity to others to see if anyone had any. So please put your questions in the Q&A. Or if you have a topic you'd like him to consider to discuss.
Yeah, and I'm again, as people are thinking, it's again always good to get perspective of what people are seeing in other regions. So I think it's good to I think have your comment, and you guys are seeing something similar. And again, there are challenges, but again, one, if we think about how to turn those challenges into opportunities, that does take more planning. Planning, I think, if there's a one take home here, it's planning. How do we deal with some of these events to our advantage? I think the word is planning. We need to plan. We need to be sort of breaking out of like those typical rule of thumbs we typically use, right? Because it might not be valid anymore with the weather, with the where the markets are, and things like that, right? So I would love to hear maybe a little bit more perspective on what people are thinking, or what else we are missing even in our research.
There's a question in the Q&A, Manny. I don't know if you can open that from Brian. He asked, do some of the climate resilience benefits come from the soil becoming a better sponge for rain?
Yeah, yeah. So again, I think it depends on what kind of soils you have, right? So again, Soil health probably is a big topic that you all have heard about. I again dive into that. That's not my expertise, right? But again, water holding capacity, if that's a limitation, that is your yield limiting factor, right? And that again, in a lot of Michigan soils, that probably is, especially southwest of our state. If you're down, further south, working on those prairie lands, it's probably not as big of a factor. It will still help, right? That if you can improve your soil health, soil structure, soil tilth, improve your water holding capacity. Now, during time of those drought years, especially at those critical crop growth and development stages, when the plant does need that water, a little bit extra does help a lot, right? So again, if you are using conservation tillage practices, or if you're looking into crop diversity, going beyond corn and soybean, bringing wheat into the rotation, getting cover crops into the system, that can all help with the soil structure, soil health. Soil again is a living system, right? We typically think about physical and chemical properties of soil, right? But soil biology, is very critical, and we are starting to learn more and more about those things, right? So I agree with the gist of the comment. I think it's a much broader topic, right? And sort of again, we have looked at some recent articles I have been involved in, have looked at, what are the relations between yield and pretty much every other factors, including some of the soil properties. It's sort of hard to find a direct correlation. If you have improve, some of these like soil organic carbon, or poxy, min c, there's multiple variables. The relation with the yield is generally not as significant as some other factors. Like in soybean world, planting date still is the main driver. Timely planting in the short term is still going to give you the most bucks. But again, every those little by little things count, right? That over time you are changing your system to your advantage. You're building resiliency into your system, if that makes sense. Anything else in the Q&A?
Yeah, one more question here. And this kind of gets to your thoughts on planting depth and singularity there. Can you talk more about the differences between a drill and a precision planter?
Yeah, so that's again, I know I didn't have enough time to spend on these things. You can see I have this slide, right, where we go into this, right? So a precision planter is again, there are multiple ways to singulate that seed, but essentially you are sort of trying to plant one seed at a time, right? So that's the seed to seed spacing comes into play. And you're also looking at consistent depth. So there's two pieces to seed placement, right? Number one is the consistency in seeding depth, which I think is the first thing we typically target. And then it's the seed to seed spacing, right? And a lot of these precision systems, most of the new ones are these vacuum based systems, right? Where you're picking one seed and dropping one at a time, right? While they're being dropped, your seed to seed spacing might not stay ideal. And companies are looking at ways, improve those seed tubes to improve the delivery once you meter that system out. But again, it does a decent job. A seed drill is very different, right? We are not singulating, right? Or we are not even metering that seed, right? It's again, it's that control fluid. It's sometime ground driven, sometime again, there are other ways, but you are not picking one seed at a time, right? It's more of a volumetric way of doing things. So you might have some control on your seeding depth, but your seed to seed spacing, that singulation is just not there, right? Even your seed depth control is just not ideal. The conventional drills don't do a good job even with the seed depth. Some of these the new air seeders, they do a little bit of a better job at seeding depth, but again, seed to seed spacing becomes a limitation. And the issue again with a small grain crop like wheat is we are planting at such a high rate, right? We are in millions of seeds per acre. compared to 30,000 or so in corn and 130, 150,000 on beans, right? We just don't have the technology to singulate the seed at these high seeding rates. And that's where going into these narrow rows, cutting down on our seeding rate are ways to again create more linear footage. So now we can take advantage of these singulation technologies, right? And that's where again, dropping below 1 million for sure in narrow rows, we are able to see some of these benefits, especially when the planting conditions are not ideal. When we have had a delay in soybean harvest, or it was again rainy, we could not get a good tillage out there. That's where the precise seed placement in a small grain seems to pay off.
Right, thank you. We'll take one more question since we're at the top of the hour. And that is, how do you have to handle people or respond to people who are hostile about climate change in your work?
Huh. Yeah, that's a much broader question, right? To me, again, I think as an agronomist, my focus is always, talk about, what are the things people are facing out there, right? So like these weather events I was talking about, I believe everyone understands that, everyone relates to that. So I can't say I have had an experience where like people, I saw hostility, right? Again, there can be those cases, when maybe you're talking more broadly. But I think when you're talking about things that people are seeing right now, or they've seen over the last 10, 20 years, there is more understanding, right? People know that, yeah, they have seen that. And again, that those are the challenges. And then you think about, or you sort of help them think about how you turn those challenges into opportunities, right? So those things I was talking about, more rainfall during spring, during fall. Folks have seen that. Everyone you talk to, who has been farming has seen that, this change in our frost timing in spring and fall. Folks have seen that, I have been living in Michigan only for 8 years, but yeah, people who have been here their whole life, they have seen those things, right? So I think if you relate what you're talking about to events that people have seen, actually, I think they probably understands and respond in a different way. So I think that's sort of what my focus has been, and I think typically I have received a pretty positive feedback from people on that. There's always, and that question is always there. So yeah, I don't know if I know the exact answer.
No, that's a great answer. No, I think that's good. We'll conclude today's webinar then. And just a note, our next webinar will be April 28th, again at 1 o'clock Central, 2 Eastern. Our presenter in April will be Dr. Sarah Sellers out of South Dakota State University. We'll talk about economics. We'll see an agronomy related to some conservation practices. And I know she looks at cover crops and those kinds of things. We do have a webinar poll. If you have a second to respond to that, we'd appreciate your feedback on this webinar. That will help us, help inform us on future events as well. So thank you, Dr. Singh, for joining us today. And we will see you next time in April. Thanks for joining.
Yeah, thanks for having me, and I'm glad, yeah, you guys have someone talking about conservation practices in the next one. I didn't have time to go in details about that, but yeah, that'll be great for your audience.
Mm-hmm. Yep, and she's